Good morning, my dear students. Now we start Unit 5 Transients, Faults, and Protection of HVDC System. So, what is meant by transients? What is the faults? Already we discussed in AC transmission system. In AC transmission system, the transients is a switching conditions. Similarly, AC transmission system, DC transmission system also have a transients and false conditions. So normally there are different types of faults in HVDC system that is a very different from the AC system. So normally the faults are in AC systems are line to line faults, line to ground faults, double line to ground faults, and also triple line to ground faults. That can be treated into symmetrical faults and unsymmetrical faults. But in case of HVDC system, we have both AC as well as DC systems. The AC having normally symmetrical and unsymmetrical faults, but in case of DC system, we using the converters. For change AC to DC causes, we need a converters. Because of converters, there is a number of faults. So according to the origin of the malfunction, converter faults can be divided into three broad categories. So what is meant by malfunction? Malfunction is a normally in converters there is a firing angle alpha. Based on that firing angle, the converter act as a rectifier, the converter act as a inverter. So malfunction means the firing angle alpha not fire exact firing angle. Means if the alpha is 30 degrees, that will fires in 32 degrees or 33 degrees or 27 or 25 degrees. This causes there is a change in wave shape, output wave shape. This is a main drawback in converter system, that is a HVDC system. So faults due to malfunction of valves and controllers, mainly arc back, that also called backfire in mercury arc valves. Second one, arc through or fire through or short through. Third one is quenching. Fourth one is misfire. Next one is commutation failure in converters. So what is a commutation failure means? Failure to complete commutation before commutating EMF reverses. Finally, short circuit within converter stations. These are the main faults occurs in HVDC system. Because of the converters, because of the valves, there is a number of faults occurs in HVDC system. So the main fault in HVDC system is a arc back or backfire. So the name indicates what is the arc back or backfire. Normally, arc back means any valve or any thyristor conducts whenever the anode is more positive than the cathode. In the similar manner, we apply the gate pulse, then only valve can be turned on. So normally the current flows from anode to cathode, which is called the forward direction. But in arc bags, the current flows from cathode to anode, means the current flows in reverse direction. So this is a very drawback in valves nothing but IGBTs or MOSFETs. So uh, arc back is a this refers to the conduction in the inverse voltage period of valves and normally happen in rectifiers. So what is the rectifiers? The rectifiers converts AC to DC because the inverse voltage period in rectifiers are more. It is common fault. So arc back is a more most common and severe malfunction in mercury valves and in random in nature. So it is a most common faults compared to different faults. Arc back is a most common. Already I told that the arc back is the current flows in reverse direction. On an average, it is one or two arc bags or valves per month. Modern thyristors do not suffer from arc bags. Factors that increases arc bags are high peak inverse voltage, high voltage jump, particularly of the jump of arc extension, high rate of change of current at the end of conduction. So the arc bags are most common in HVDC system. The current flows in reverse direction. Next one is arc through. Arc through. So it occurs during the blacking period of the wall when the voltage across it is positive. Since the wall voltage is more positive in inverter, this malfunction is more common on inverter side. Arc back is most common in converters. Arc through is most common in inverter sides. So in HVDC system presents both rectifiers and also inverter sides. So arc back and arc throughs are most common in HVDC system. But now in modern trends, modern days, arc back and arc through are very rare because of implementation of valve manufacturing. It is similar to commutation failure. Arc through also similar to commutation failure. So what is the commutation? We know that commutation is a current transfer from positive valve to positive valve. How to current transfer from positive valve to positive valve is a commutation. So if the commutation fails, so the current transfer fails, there is a malfunction in the operation that causes severe problem in system. It is similar to commutation failure. So the main characteristics of arc 3 is a failure of negative grid pulse, early occurrence of positive grid pulse, sufficiently high positive transient over voltage on grid or anode. Next one is a misfire. The name indicates there is a misfire. Arc back and arc through. Arc back in rectified side, arc through in inverter side. The misfire occurs in both sides, in rectified side as well as inverter side. So the failure of valve to conduct during conduction period is misfire. So misfire means where the exact firing angle that not fires the valve, that is a misfires. The angle will be deviated. The firing angle or extinction angle gamma is deviated. This causes lot of changing output waveforms, the output not occurs properly. So the misfire where as arc through is the failure of valve to be blacked during scheduled non-conducting period. It can occur in rectifier or inverter, but is more severe in inverters. So normally the misfire is common in both rectifiers as well as inverters, but the misfire is most common in inverters. It may be due to negative gate pulse or positive anode to cathode voltage or fault in valves. The effect of misfire in inverter is same as commutation failure and arc through. The characteristics of commutation failures and arc through is nothing but misfire. The main drawback of misfire is the change in wave shape is abnormally. Next one is a commutation failure, very serious problem in converters. The failure of two successive commutation in one cycle is double commutation failure. So the failure of two successive commutation in one cycle is a double commutation failure. There is a single commutation failure as well as double commutation failure. The failure of two successive commutation in one cycle is a double commutation failure. Let us take an example that valve 1 and 2 are conducting and 3 is to be ignited and is to take complete current of valve 1, which is upper limb of converters. Normally, suppose there is a 6 pulse converter, valve 1, 3, 5 in positive mode of operation, valve 2, 6 and 4 in negative limb. So the current normally transferred from positive mode to positive mode. So once the current is transferred from sometimes the current not transfer from positive to positive properly. It is nothing but commutation failure. So at a time, two valves are conducting from positive side or negative side is called is a commutation failure. This is a most severe problem in converters. Let us take an example that valve 1 and 2 are conducting and 3 is to be ignited and is to take complete current of valve 1, which is upper limb of converter. If current in incoming valve 3 diminishes to 0 after full conduction, the current in valve 1 will continue to carry full DC link current. Firing of valve 4 in next sequence will result in short circuit across bridge as both valve in same valve will conduct. If the commutation from valve 2 to 4 is successful, then only valve 1 and 4 will conduct. Suppose in 6 pulse conductor at a time two valves must be conducts, one from positive mode, positive to positive thyristor, another from negative thyristor. Normally the current is transferred from positive thyristor to positive thyristor. In commutation failures, the valve 1 is conducting similarly in the same time the valve 3, which is in positive group, valve 3 also conducts. At a time two positive thyristors will conducts. This is the commutation failure. This is also called as a overlap period. So commutation process. Please see the commutation process. So here there is a thyristors 1, 3, 2. 1 and 3 belongs to same category, that is nothing but positive mode of operation. 2 is in negative mode of operation. Let SCR1 and SCR2 are conducting and current is to be commutated from SCR1 to SCR2. 3. SCR1 to SCR3. Commutation can take place as long as voltage difference VB minus VI is positive. This voltage difference is referred to as commutating voltage. The commutating voltage can also be described as the reverse voltage across the SCR terminals that helps to turn off conducting SCR. The commutating voltage drives a commutating current through SCR1 and SCR3. This commutation current will help increasing current in SCR3 and decrease current through SCR1. This is a commutation process. Please observe the diagram. Normally the current is transferred from valve 1 to valve 3. So valve 1 and valve 3 is a same group, valve 2 is a reverse group. Please observe the diagram.